There are all sorts of tips to help make your SwiftUI code as fast as possible. But you should always start with a simple rule. The fastest code is the code that never executes. In SwiftUI terms, this means taking steps to try and not do work as much as possible, or at least delay it as much as possible. For example, if you're updating your UI as the user interacts with it, does it have to update for every single letter they type into a text field? Or every pixel they drag a slider? If you are making a QR code from the data, or perhaps using the SpriteKit water shader from earlier, it's clearly overkill to re-render the whole thing for every slider drag. Now, for many operations, you'll find that introducing a small debounce dramatically improves performance while sacrificing little to none of your user's experience. A debounce is a practice of waiting some amount of time before taking an action. For example, if we're debouncing a text field by 1 second, the user must stop typing for a full second before we update our app state. They can type as much as they want to, for as long as they want to, and no work will happen until they finally stop for a full second. Even a debounce as low as 0.1, like a tenth of a second, can lead to huge performance improvements because the alternative might be 120 frames a second. That equates to just 0.008 of a second. So 0.1 is a huge difference. Now you can implement a simple debounce system generically using Combine. This will be generic over some kind of T, so you don't really care what kind of data we're trying to debounce. It'll also have two published properties, one for the input value and one for the output value. The input value will always be the latest value from the user, and the output will always be the latest debounced value. And it'll have a private anyCancelable property that stores the actual debouncing work. This comes from Combine and allows us to cancel the work if needed. So, start with this. First, import Combine. Then make a class called debouncer. Generic over T is an observable object. We'll publish the input of T and publish the output of T. And then we have the private var debounce. This is an anyCancelable optional. Now we've got a write initializer here that accepts two values from the user. The initial values are used for both the input and output values, the same to start with, and also how long we want to make our debouncer wait for. The way this works is simple. Elsewhere in SwiftUI, we'll adjust the input value directly, right? But we'll attach that to Combine's debounce and sync operators, so that after a period of time has passed, we copy the value from input into output. And because output is also published, it will cause any observing SwiftUI views to reinvoke their body property. And so go ahead and add initializer now. Init with initial value of T and a delay double of 1 by default. We'll go ahead and copy initial value into input and also output, the same when we start, and then make our debounce object. And this will be the input publisher debounced for seconds of our delay value using dispatch queue dot main for the scheduler. So wait that long, and then sync it using weak self in. Then we'll say in not input in self.output equals $0. And that's it. That's our entire debouncer class done already. To try it out, just make an instance of it using state object and then bind things to input and your readouts to output. For example, we could say I want to debounce a text field and a slider. I could say something like at state object private var text is a debouncer. Initial value empty string. Delay, let's do 0.5, so quite fast. And at state object private var slider is another debouncer. Initial value 0.0, delay 0.1. And then in our body here, I'll say there's a vstack with a text field inside. We'll do a prompt of search for something, binding the text to $text.input. Write that text directly to the input value to be debounced into the output. I'll do a text field style of rounded border. And below that will be a text view with text.output, showing the debounced version of it. Then we'll do a little spacer perhaps spacer with a frame height exactly at 50, and a slider with a value bound to $slider input in the range 0 through 100, a text of slider.output formatted. Like that. Let's give it a try in our little canvas here. Let's add a bit of padding below it so I can see things more easily on the screen. Boom. As I drag the slider around, nothing's happening. It's not firing. If I stop, boom, updates straight away. It updates after a tenth of a second. That's really, really fast. Release, boom. And this one waits a half second. So I'll type hello world. Boom. See updates really, really nicely as I type. But it waits till I finish typing and then a half second afterwards. And you carry on typing, it never updates. So it's not like it's doing many, many pieces of work on a simple delay. A debounce means it'll only do the work once after the time has passed. Now, for work that takes place outside of bindings, you really want to be using Swift's task to spin off the work, then sleep for some amount of time, and then run it after some kind of delay finishes. And this works well because if you want to schedule the same work again and again, while the sleep's happening, you can just cancel the task and schedule it again. It's debouncing, just done without combine, right? As an example, we can make a view model that can do some work for us immediately or schedule some work to happen after a short delay. So I'll say the class called viewModel, which is an observable object. I'll give this thing the refresh task. This is the one doing the work of refreshing either now or later on. This is a task with no value coming in and might have an error coming back. Then we have our work counter, the thing we're going to do work internally. Then I'll say we have a method called doWorkNow. It does the work immediately. So I'll say work counter plus equals 1, and then print work done with work counter. So you can see it's happening behind the scenes. We'll also say I want another one called schedule work, like this. And this does it after a delay. So if we're calling this, make sure first we have cancelled our current task. So I'll say refresh task dot cancel, just in case it hasn't, so it's currently sleeping in its time. Then we'll say our task is a new task where we try waiting using task.sleep until now plus seconds 3 on the continuous clock. And then when that sleep wakes up, we call doWorkNow. Like that. If you need to support Apple's older OSs before the continuous clock's available, so that's iOS 15 earlier, for example, macOS Monterey earlier, you should use try-await task.sleep using nanoseconds instead. So you want to say, 3 billion nanoseconds, for example, rather than 3 seconds. Anyway, this view model exposes both doWorkNow and schedule work, so you can choose which one you use depending on the circumstances you have. So you might say here that I want to have private var view model is a new view model. You are so hungry today. You get fed all the time, you know. VStack here, button of do work soon, action bound to view model dot schedule work. But then we'll also have a button of do work now and action there of view model dot do work now, like that. So with that in place, we should get a new preview shortly. There we are, 2 buttons. If I run these back, we should see these buttons, and I'll press do work now. It runs immediately. Work done 1, 2, 3. I press do work soon. Click, 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 click. Work done. So it's the same kind of thing. Now, if I press do work soon, then press it again, then press it again, it's cancelling the task each time. The time has not elapsed yet. It's being cancelled and reset every single time, like a real debouncer would. If I press it one last time and wait, eventually it'll run that task and say work done 5. There we go. So it works really, really nicely without combine.